Hi, folks. We've said in order to get formal proof practice, what you need to do is focus on those equivalences and prove both directions. In this video, we'll talk about one of the more difficult distribution equivalences, where you actually have to distribute this in twice in order to get this wide scope conjunction. So start with this premise, assume this disjunction in line number 1, and tell me how many lines it takes you in order to prove this conclusion. Pause your videos now and try to work this out with pen and paper and decide what your answer is. Okay, what I want to know is, what did you do first? The first thing I did is I looked at the main connective of my premise. That's always the first thing you should do. And since this is a wide scope disjunction, it tells me what to do. I need to do proof by cases. Disjunction elim is the solution. So how do I start that? What do I do next after I know I'm doing disjunction elim? I need to start my first case. So what I did is I took the first disjunct and put it in the assumption line of a subproof. There's no guesswork or even no difficult detective work you have to do. If you're wondering, okay, I think I should do disjunction elim, but I don't know what to put here, you have to remember how disjunction elim works. You just take each disjunct and put it in its own case. So that's why I just pulled down A and B and put it in an assumption line here. Then, of course, anytime you get new information, look at the main connectives of it too. That's how I knew, since this is a wide scope conjunction, that I just need to bring down each of those conjuncts. What am I going to do with those conjuncts, of course? This is where I need to go back and think about what my conclusion is, because these are literals. Once you bottom out in literals, you need to start looking around to other bits of information. For example, the main connectives of my conclusion. This is a wide scope conjunction. Now, how do you prove a conjunction? You're going to prove the individual bits of it and then put them together. Conjunctions are just like Lego pieces. You can take them apart and put them back together. So I need to prove A or C, and I need to prove B or C. This gives me a plan in order to build each of these conjuncts. So since I have A, I know that I can prove each of those bits. I can get A or C by using A and disjunction intro. I can get B or C by using B and disjunction intro. So I can actually individually assemble each of those bits and then finally put them together. So if you want all the citations, here's what it looks like. I cite this big long conjunction intro, and I cite 4 things. Now, you might have been tempted to put them together individually first. Like first you put A or C and B or C together. But if you do that, you're going to end up with different scope lines. You see, these 3 conjunctions in my conclusion are all of equal scope. There's no extra parentheses, which means I need to put them together all at once. When I cite conjunction intro, the number of lines I cite is 2 or more, depending upon how many conjuncts I need to throw in there. So given the scoping is like this, that's why I did conjunction intro all at once. Now, contrast it with this example. What if my conclusion that I wanted was actually this thing, where I did some associativity, and I grouped these first 2 by associativity, and I grouped the latter 2 by associativity? If the grouping is in there, then I need to build them up with that grouping as well. I would first have to build A or C and B or C. So there's my conjunction intro on 2 of them. And then I build my other one with conjunction intro on 7 and 8. If I put these things together, then that conjunction that I just built is going to be the main connective. So depending upon how the associativity grouping is, that tells you whether you assemble it in multiple steps or whether you assemble it all at once. And given that our conclusion here was a bunch of coordinate conjunctions, all of the same scoping, that's why I did it all at once. Okay, now, if you didn't complete the proof in its entirety, pause your videos now and see if you can complete the other case. All right, that was your last chance to jump on board. Now, this ends this case because we've already got to our conclusion. And proof by cases says you need to prove the exact same sentence in each case, which is almost always your ultimate conclusion. So the next thing I did is I assumed my other disjunct, C and D. And then, since that's a conjunction, I brought those down. Notice this is pretty similar. I need to build up each of these disjunctions and then finally complete it. So if this is what you have, then great, keep watching. If you didn't get this, pause your videos. You fill in these justifications before I do. Even if you're not bothering to do the work and write it out on pen and paper, pause your videos and tell yourself in your mind how you would justify each of those. Okay, here's the answers. First, I'm just doing conjunction elim on 10. Then I'm doing disjunction intro. You have to pay attention. The first 2 are coming from C. That's why they both say 11. And then the next 2 come from D. That's why they both cite 12. And then again, I'm putting all of those things together, 13, 14, 15, and 16. Don't put a dash here, because if you put a dash, that's how you cite a subproof. But I'm actually citing these 4 individual lines. That's why they need to be separated by commas. Now, finally, once I proved that sentence in both cases, I exported out of those subproofs with my disjunction either rule. There was no mystery as to how to cite my final conclusion. I just have to ask myself, why did I start those subproofs in the first place? And I did it because I knew a disjunction, and I'm doing proof by cases on it. So I have to cite disjunction them, my disjunction, which was line 1, the original premise, plus my first subproof, which was 2 through 9, I believe, if my memory is right, and the second one, 11 through 17. So 18 lines. That is the answer I was looking for doing the final proof. Okay, thanks.